In this video, we're going to talk about how the vertex form allows us to solve for x values given the y values. So in this case, our y value is what we're calling the height of an object, and t is the time passed in seconds. So a missile is fired upwards at an initial speed of 128 feet per second from a tower 100 feet off the ground. Its height as a function of time is given by h of t equals, so h is the height of a missile in feet, dependent on the time in seconds since it was fired. Okay, so by the way, negative 16, the reason this is here is because that's a gravity constant. The change in the speed of an object as it's falling is negative 32, so the speed actually increases towards the ground at 32 feet per second every second. First thing we want to do is write the equation in vertex form. So the first thing we need to do is find the vertex, which is given by, I shouldn't use x since my x here is actually t. So t is equal to negative b over 2a. Now b is 128 and a is negative 16. So this gives me the opposite of negative 16 divided by 2 times a. And, oops, I plugged in the wrong value here. There should be negative 128. And so when I divide these out, I get 128 divided by 32. That goes into it 4 times. So I get time is 4 seconds. Oh, and by the way, how does this thing look? Well, we start at 150 feet. It's fired upwards, and the rate of change is decreasing, eventually going to come down and hit the ground. So this is height and this is time. Okay, so at 4 seconds, we're claiming that that's when a maximum occurs. And to figure out what the height will actually be, I will find h of 4, which is negative 16 times 4 squared plus 128 times 4 plus 150. So when I do that, I get negative 16 times 4 squared plus 128 times 4 plus 150. I get 406 feet. So that means this point right here, this vertex, occurs after 4 seconds, and the missile goes up to a height of 406 feet. So it goes up pretty high. It gains about 256 feet before it begins to descend down towards the ground. Okay, so we're gonna write. Oops, we're not done. We want to write this thing in vertex form. So we know that a vertex form would be, in this case, y equals the a value times the x value minus the horizontal component of the vertex plus the vertical part of the vertex. So in this situation, we would have a is negative 16, t minus h. That's the horizontal part of our vertex. So that's the 4, t minus 4 squared, plus the vertical part, which is 406. So based on this idea of foiling, what we usually refer to as foiling, we can actually figure out whether this thing, we claim this to be the same as the original function, but is it really? So one thing to look out for when you're trying to expand this thing back out is it's tempting to want to do t squared minus 4 squared. But remember, that doesn't work because taking t minus 4 and then squaring it is not the same thing as taking t squaring it and taking minus 4 and squaring it. For example, put in 5 for t. Well, 5 minus 4 squared would be 1 squared, which is 1. But 5 squared is 25, 4 squared is 16, and 25 minus 16 is 9. So those are not the same things. So when we write it as the definition of a squared intends us to write it, t minus 4 times t minus 4, we have this idea of foiling, and depending on which method you want to use, I'll just do the quick method. So we have negative 16 times t squared minus 4t minus 4t. Negative 4 times negative 4 is positive 16 plus 406. Okay, so it's beginning to take shape. I'm going to combine like terms in here. So I've got negative 4 copies of t and negative 4 copies of t. So I have negative 8 copies of t. Plus 16 plus 406. Well, hey, check